This is experiment A21, air conditioning process. After watching this video, you should be able to understand the air state changes within various sections of an air conditioner and become familiar with the complete air conditioning process. The equipment we are going to use for this experiment is the air conditioning laboratory unit A574 made by PA Hilton Limited. It is a self-contained laboratory unit with all the instrumentation included. This is a schematic drawing of the air conditioning laboratory unit. Please familiarise yourself with this equipment. There is a centrifugal fan on the left hand side connected to an air duct. An evaporator and two reheaters, each of 1 kilowatts, are installed within the duct. There are 4 sets of thermometers at different locations, points A, B, C and D, along the air duct. A is at the fan inlet, B is after the preheaters, C is after the evaporator, and D is after the reheaters. At each point there is 1 dry bulb thermometer and 1 wet bulb thermometer. These thermometers are used to indicate the changes of thermodynamic properties of the air in the air conditioning process. At the bottom of the unit are the compressor, condensing unit, and the thermostatic expansion valve. There are 3 dry bulb thermometers, which measure the refrigerant temperature as it leaves the evaporator, point 1, before the expansion valve, point 3, and as it enters the evaporator, point 4. There are also 2 pressure gauges measuring the pressure of the refrigerant leaving the evaporator, point 1, and before entering the expansion valve, point 3. On the right hand side, at the end of the air duct, there is an orifice. An incline manometer is used to measure the orifice differential pressure. Add water to the 4 wet bulb thermometers and ensure that they remain wet throughout the whole experiment. Adjust the reading of the incline manometer to 0 before energizing the unit. Let's go to stage 2. Now you can switch on the unit at the main switch and power switch. Set the fan speed at the maximum, 60%, by adjusting the fan speed controller. Then switch on the compressor using the switch on the control panel. Since the refrigeration system in this unit is an air-cooled package condensing unit, once the compressor is on, the associated condenser fan is switched on simultaneously. In this experiment, there is no preheater installed. Only the air reheaters are used, so please do not turn on any other heater switches on the control panel. Switch on both the air reheaters. Run the unit for a period of 5 minutes to stabilize the operation. This is the observation sheet provided in the lab manual. Record the temperatures, airflow rates and pressures at the points A, B, C, D, 1, 3 and 4. Note that the values obtained from the pressure gauges are gauge pressures. Absolute pressure is the sum of gauge pressure and atmospheric pressure. The air condition at point A may be regarded as the ambient condition. There may be a measurable difference in the temperatures at points A and B. Explain why in your logbook. Air at point C is cooled and may be dehumidified depending on the ambient conditions in the laboratory. The air at point D should have the same moisture content as that at point C. The air mass flow rate is obtained from the incline manometer reading using this equation, where M subscript A is the air mass flow rate, Z is the orifice differential pressure, which can be read directly from the incline manometer, and V subscript D is the specific volume of air at point D, which can be obtained from the psychrometric chart. The refrigerant mass flow rate, M subscript R, is obtained from the refrigerant flow meter. After collecting all the data for the first test, reduce the fan speed to 10% and switch off one of the reheaters. Keep the operation of the refrigeration circuit unchanged and wait for 5 minutes for the unit to stabilise. Once the unit has become stable, repeat the above procedures and record the data for the second test. After collecting all the data, you can stop the unit. First, turn off the heaters and then the compressor, set the fan speed to 60% and allow the fan to run for 5 minutes. Afterwards, you can switch off the power switches. This is the end of this experiment.